Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Warina Izzat Masha. Today I'll be presenting. Today, me and my group will be presenting a chapter understanding key terms in astronomy. So in this topic, there will be four main sub-chapters that will be presented. So let's start with the history of the universe. Our universe has come a long way. The formation of our universe consists of complex process and journey. It is much easier to explain the history of the universe by focusing major events in which I've broken into 6 parts. So this is the part that I talked about previously. So let's start with the Big Bang. This is an artist's impression of the Big Bang. So let's start with the Big Bang. The formation of the universe started with the Big Bang. What is the Big Bang? It is an explosion where result hot matter, rocks flying all directions in the speed of light. After the event of the Big Bang, matter, energy, space, and time are created. Interestingly, though, the event of Big Bang was mentioned in the Quran in the Surah Al-Anbiya. So this is the picture of the Milky Way. Okay, before I continue the history about Milky Way, I would like to explain a bit about Milky Way so you have a better understanding about the universe. So why they call it Milky Way? So long ago, people look up in the sky and it looks like someone spilled milk up in the sky. We can only see the Milky Way when our around surrounding is pitch black dark. What is so significant about the Milky Way? It's where our solar system at. Basically, it's our solar system is where the the Earth located at, and the Sun, and the Mars, and the Moon. So astronomers have agreed that Milky Way probably had two major spiral arms, which is right here, the Perseus arm right here, and the Scrotum Centris arm. And the solar system located between two arms called the Orion Cygnus arm, which is right here. So this is where our solar system at. So let's go to the history of the Milky Way. So the birth of Milky Way, which was 12.5 billion years ago, Milky Way during this time was not as today as we see it today. During the earliest form of the formation of Milky Way, it just looked like a circular blob. Like many other galaxies, Milky Way formed roughly 200 million years ago after the event of Big Bang. During this time, our sun and planet also gravitates uh, each other and start form a new other galaxies. So let's start at 5.5 billion years ago, where the solar nebula began collapsing. So what is solar nebula? Solar nebula consists of ginormous cloud, interstellar gas, and dust. Solar nebula is what triggered the the formation of our sun. The sun was complete form 4.6 billion years ago. During this time, Milky Way has become as it is today. So 4.5 billion years ago, our Earth was formed after the formation of Sun completed. At the first phase of the creation of the Sun, it was too hot for any living creatures to survive because the Sun was too hot. Until around 3.9 billion years ago, the temperature was much more become habitable, and the first living creatures start to live on the Earth's surface.
Hello guys, I will continue my presentation, which is I will start with my part. It is about the scale of the universe, right? But first of all, I will share about definition of universe. Okay, universe is everything, which means it includes all of space and all the matter and energy that space contains. It even includes time itself and ourselves. Earth and the moon are part of the universe, as are the other planets and their many dozens of moons, along with asteroids and comets, the planets orbit of the Sun. The Sun is one among hundreds of billions of stars in the Milky Way galaxy, and most of those stars have their own planets, known as exoplanets. The Milky Way is but one of billions of galaxies in the observable universe. All of them, including our own, are thought to have supermassive black holes at their centers. And all the stars in all the galaxies and all the other stuff that astronomers can't even observe are all part of the universe. So the universe is very wide and so big as can we want to look the universe. Now, we continue mostly popular question, which is what is a planet? This seemingly simple question doesn't have a simple answer. Everyone knows that Earth, Mars, and Jupiter are planets, right? But both Pluto and Ceres were unconsidered planets until new discoveries triggered scientific debates about how to best describe them. A vigorous debate that continues to this day. The most recent definition of a planet was adopted by the International Astronomical Union in 2006. It says a planet must do three things, which is first, it must orbit a star in our cosmic neighborhood, the Sun, and the second is it must be big enough to have enough gravity to force it into a spherical shape. And the third is it must be enough that is gravity clear away any other object of a similar size near its orbit around the Sun. Contemporary observations are changing our understanding of planetary system, and it is important that our nomenclature for object reflect our current understanding. This applies in particular to designation planets. The word planet originally described wanderers that were known only as moving lights in the sky. Recent discovery led us to create a new definition which we can make using currently available scientific information. The IAU defined a planet for new definition is a celestial body that is in orbit around the Sun and has sufficient mass for its self-gravity to overcome rigid body forces so that it is assumes a hydrostatic equilibrium nearly round shape. And the third has cleared the neighborhood around its orbit. So there is some definition of a planet. Okay, now you get it. And I will pass to the next presenter. Thank you.
My name is Amira Safia binti Ahmad Azli. Let's move on to the next topic, which is properties of light and matter. First is light and color. How do we experience light? We experience light with the warmth of sunlight tells us that light is a form of energy. Other than that, we can measure the flow of energy in light in units of watts. 1 watt equal to 1 joule per second. Light also comes in many colors that combine to form white light. There is some interaction between light and matter, and the first is transmission. Transparent objects transmit light and opaque objects block light. For example, passes through matter such as a window. The second is emission, which is matter can emit light. Something sent forth by emitting such as an antenna and the sun. Next, absorption, that matter can absorb light and transfer light energy to matter. Lastly, reflection. Light can bounce off matter and changes direction of light, for example, like a ball bouncing off ground. The second subtopic is properties of light. Light can act either like a wave or a particle. Next, waves and particles of light. A wave is a pattern of motion that can carry energy without carrying matter along with it. There are two properties of wave. First is wavelength, being the distance between two wave peaks, and frequency is the number of times per second that a wave vibrates up and down. Next, particle of light. Particles of light are called photons. Each photon has a wavelength and frequency. The energy of a photon depends on its frequency. There is a formula which is wavelength multiplied by frequency equal to speed of light. The electromagnetic spectrum is a continuum of all electromagnetic waves arranged according to frequency and wavelength. The entire range of wavelengths of light is known as the EM spectrum. EM wave typically described by any of the following three physical properties such as frequency, wavelength, and intensity. The EM spectrum is divided into 7 regions in order of decreasing wavelength and increasing frequency are radio wave, microwave, infrared, visible light, ultraviolet, UV, X-rays and gamma rays. The visible spectrum is part of the EM spectrum can be detected by the human eye is called visible light. The visible spectrum, which is red, orange, yellow, green, blue, indigo and violet. The violet color has the shortest wavelength and for the frequency is the highest, while red color has the longer wavelength and least frequency. Please take note that wavelength is inversely proportional to frequency.
We will go to the properties of matter. In this topic, we will learn about 3 subtopics, which is the phases of matter, the structure of matter, and lastly, the energy stored in atoms. Matter is what the universe is made up of. As we can see in the picture here has 4 phases of matter. We have solid, ice, so that would be water in a solid form. Next is liquid water. And next we have gas, that going to be a lot of water suspended in the air. So that is what universe is made up of. And what is matter? Matter is anything that has mass or that takes up space. Even though the mass or the spaces that takes up is really tiny, as long as it has some of mass or takes up some of spaces, it is classified as matter. But what is the matter made up of? As you can see in this picture, we will start with matter. For example, the red block is the matter, which is an object. So we can clearly see the matter, right? But what you can't necessarily see from this picture is atom. Atom is what makes up this red block or the matter. Atom is very tiny and all matter is composed of atoms, which can be considered as the building block of matter. Atoms is the smallest unit of matter and it sticks a bunch of atoms together, and that is how we get things like the red block. However, atoms is not the smallest thing that exists in our universe, even though we consider that atoms as the building block of matter, but there is a very smaller things that makes up atoms, which is electrons, protons, and neutrons. So, basically, proton is particle in nucleus with positively charged, and neutron is also particle in nucleus but with no charge. Last but not least, electron particle in a cloud around the nucleus with negatively charged. And lastly, we move to the energy stored in atoms. Did you know an atom have energies? When we talk about the energy of an atom, we will be thinking of the internal energy, which is energy of motion and position of the particles that make the body, such as the sum of the kinetic energy of the particles inside the ball, just like in the video. Next, we will talk about the Doppler effect. So, in this picture, we will learn about the Doppler effect for light. But before that, we need to know that the Doppler effect is the effect that we think of whenever we hear a car or a train passes by or anything that causes the sounds to change their pitch as the object passes us by. So, let's look to what that means for sound, and then we will move to see how this applies to light. For example, we are standing by the road and an ambulance approaches and passes by. First of all, as the ambulance approaches us, the sound wave produced in front of the siren will be compressed together as the ambulance moves towards us. These compressions of the sound wave give a higher frequency or high-pitched sounds like this. But as the ambulance moves past us, we will hear the sound exactly as it's produced like this. As the ambulance moves away from us, the sound waves from behind the ambulance are stretched out, giving a low frequency sound or low pitch like this. So that's it. So it's the same thing can be seen with light wave, particularly light wave produced by stars. From an observer, if a star was moving towards them, the light wave produced by the star in front of it would be compressed together and giving a high frequency light wave. High frequency visible light is a blue color that call it as blue shift. But if the star is moving away from an observer, the light wave produced behind the star will be stretched out and it will give low frequency light wave. Low frequency visible light is a red color that call it as redshift. This can be seen with stars when we look out in the universe that the stars have a redshift, showing that all the stars are moving away from us. This indicates that the space between stars is getting bigger as the universe is getting bigger also. So, what we can conclude is the further away the stars are, the bigger we see the redshift. And the universe must be continuing to expand. That's all about the properties of matter and the Doppler effect and Doppler of light. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amira Nabila binti Azman. So right now, I will present the chapter about pattern in the night sky. Shortly after sunset, as a daylight fades to darkness, the sky appears to slowly fill with stars. On a clear moonless night, far from city lights, more than 2,000 individual stars may be visible to your naked eye, along with the whitish band of light that we call the Milky Way. As you look at the star, your mind may group them into patterns that look familiar in terms of object or shapes. If you observe the sky night after night or after year, you will recognize these same patterns of star, and these patterns have not changed noticeably in the past few thousand years. Okay? Next, what is a constellation? Constellation are a group of stars that form a specific pattern and are recognized by mythological figures and have name attributed to them. Constellations are used for the study of astronomy. According to modern astronomy, the constellations are defined and recognized areas of the sphere called the celestial sphere. These defined areas of constellation are internationally recognized when prominent stars which are at certain proximity to the other star are grouped around an asterism in the night sky of Earth. They form constellation. On modern star chart, the entire sky is divided into 88 regions or 88 constellations. Every star in the sky is within the boundaries of one of these constellations. Astronomers use constellation to roughly identify and observing the area of the sky. Most of constellation names we know came from the ancient Middle Eastern, Greek, and Roman cultures. They identify cluster of stars as a good, goddesses, animal, and object of their stories. In some cases, the constellation may have had ceremonial or religious significance. In other cases, the star grouping help to mark the passage of time between planting and harvesting, such as Orion. In Greeks, represent a hunter and includes a body that wields a sword or club. But ancient Egypt associated the Orion's constellation with Orisis, god of death, afterlife, and rebirth.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Huda Akilah binti Abdul Razak. I will present the motions of the celestial sphere subtopics. So, basically the illusion that all stars are next to one another in the sky occurs because we lack of that perception when we look into space. A result of the fact that the stars are so far away. The ancient Greeks mistook this illusion for reality, imagining that the stars and constellations to lie on a great celestial sphere that surrounds Earth. Although no such sphere exists, we still use this convenient concept to locate the stars and the other celestial objects. Celestial sphere is an imaginary sphere of infinite radius with the Earth as its center, and also being used for describing the positions and motions of stars and other objects. For an observer anywhere in the northern hemisphere, the north celestial pole is always above the horizon. As Earth turns from west to east, it appears to the observer that the celestial sphere is turning from east to west. Stars sufficiently near the north celestial pole revolve around the pole, never rising or setting, and such stars are called circumpolar. Stars near the south celestial pole never rise above the horizon at all. All other stars have daily circles that are partly above the horizon and partly below it, which means that They appear to rise in the east and set in the west, and so this just shows you on the bottom what the star trails would look like if you are at different regions. So we saw for our location in the last image what it would look like at middle latitudes at the North Pole. It would just look like the stars all go around you, since you are the center of rotation up there, and at the equator it look like they will move straight up and down. Next is measurements using the celestial sphere. The celestial sphere is a useful tool for describing the locations of objects in the night sky. However, when you go outside, you can see only one half of the celestial sphere from any particular location, the other half being blocked by the ground from view. The location of any object in the sky can be described by its direction along the horizon and its altitude above the horizon. The direction is usually measured in degrees clockwise from due north in this figure. For example, the location of the object being described is located at 90 degrees along its horizon, or simply due east, and has an altitude of 50 degrees above the horizon. So this is one way to quantify where something is. And lastly, the angular sizes and distances. There are some ways to make some estimates. The angular size or angular diameter of an object is the angle that it appears to span in your field of view. For example, as the angular size of the sun and moon are each about half a degree. Note that the angular size does not tell us on its own of the object's true size. So the sun and the moon both have the same size in our sky, but we know they are very different in sizes, that the moon is much smaller than the sun. It just happens that the sun is far enough away that it looks to be smaller. The angular distance between a pair of objects in the sky is the angle that appears to separate them. For example, the angular distance between the pointer stars at the end of the Big Dipper's pole is 5 degrees. You can use your outstretched hand to make rough estimates of angles in the sky. So the width of your index finger, about a degree. The width of your palm is about 10. And then your 3 knuckles of an index finger from the outside in are 3, 4, and 6 degrees. Of course, it's on average, so we can make some estimates at least.
Okay, hi, Assalamualaikum. My name is Nurhuda binti Mazuki. So I will continue to findings number 4, which is reading from star map. As you all can see, a circle on the slide. If you want to know, this is a star map. It's also called as a sky chart or sky map because this is a map of the night sky. Star maps are used to identify and locate constellation and astronomical objects like stars, nebula, and galaxies. They also have been used for human navigations since time immemorial. Okay, when stargazing, the naked eye can make out over 6,000 stars, 88 constellations, tons of faint fuzzies, 5 planets, and 1 moon. However, you may struggle to see what's what if you are unfamiliar with the star map. A star map helps you to learn the constellation, the stars, and faint fuzzies within them. Okay, a star chart is essentially a map of the night sky. People have studied the stars for thousands of years, dividing the sky into grids. The grids help people to locate and identify constellations, stars, and galaxies. The oldest known star chart was discovered in Germany in 1979 and is believed to be 32,500 years old, worlds away from today's star chart. The map was carved onto an ivory mammoth tusk and contained the constellation. Okay. Point number 1, big dot and small dot. Okay, as you all can see on the star map, they are represented by big dot and small dots, or more correctly is a circle. Most star maps use different size of dots to show the brightness of stars. Stars are represented as black dots on a white background. The size of the dots reflect the brightness of the stars. The largest dots are the very brightest stars, and the smallest dots are the faintest stars that you will be able to see from a rural sky. Some star charts have a wider range of circle size, to include very faint stars that can only be seen in certain conditions or with a telescope or binoculars. Okay, next we continue to constellation lines. As you have seen for presentation about constellation, we all know a constellation is a recognized pattern of stars in our night sky. Okay, for constellation lines, this is a line that connect the star to make a constellation. We can join up the brightest star in a constellation on a star map with lines showing the general outline, or maybe just the brightest asterism within and among the constellations such as the Big Dipper or the Summer Triangle. Although the boundaries of all the constellations are very well defined, the way stars are joined within a constellation to make a pattern may vary slightly from map to map.
Greetings, I am CTU500 binti Ahmad Suhaimi. Let's proceed on the next point, which is double and variable stars reading from star map. Double stars or binary stars generally is a star system consisting of two stars orbiting around their common barycenter. Instead of double stars, they are also called as multiple stars system. There are four types of double stars. Firstly is visual binaries that can be resolved through telescope. Second is spectroscopic binaries, which stars in a single system are too close and only can be seen as separate stars through spectral analysis. While eclipsing binaries are secondary stars that orbiting the primary that causing light output is fluctuate. It is the same concept to moon or sun eclipse. And the last one is optical doubles, are two unrelated stars that lie along the same line from the side of the Earth. Basically, variable stars are stars that change its luminosity not due to an eclipse, but to some sort of physical characteristics. There are three types found for variable stars, which are eclipsing binaries, pulsating variable stars, and eruptive variable stars. To read a star map, we should know on the coordinate lines, which is in order to estimate and observing stars, we have to know what is coordinate lines. Let's look on the globe. Globe is representing the Earth, which rotates in its own orbit, and Earth's axis of rotation is tilted with respect to its orbital plane, latitudes and longitudes. To identify both are by knowing location of equator and the prime meridian on the Earth. So, latitude is measurements on a globe of location north or south of the equator, while longitude is measurements of location west or east of prime meridian. However, in determining stars that lie outside of Earth's atmosphere, astronomers measure it by right ascension and declination, and it has the same concept to latitudes and longitudes, which are right ascension is longitude and declination is latitude of the celestial sphere. Therefore, determination of right ascension and declination is a must on reading the star map. As for conclusion, astronomy is a field where people learn the universe. The universe is vast, with so much left to discover. At the same time, this reminds us that the creator of the universe is the greatest. Only that from us. Thank you.